everybody. Welcome to day 2. My name is Rob Zazueta. I'm our Global Director of Digital Strategy at TIBCO, which means I get to go around and tell our customers how they can make money off the stuff they buy from us, which is pretty cool. And surprise, surprise, today I'm talking about microservices. So before we start going too deep into this Wrangling concept and this management concept, I kind of want to spend a moment level setting. Because I still find that when I'm talking to customers and people who are looking at implementing a microservices architecture, there's still sometimes a little difference in opinions. We start getting caught up in the technology and not so much caught up in the functionality like we should be. So people tend to define it by containers or by APIs or by the different kind of structures that are out there. So we just purchased a company, TIBCO purchased a company called Nanoscale, and my colleagues there created this very nice, concise definition that I really like a lot. Architectural approach to developing an application is a suite of small services, each running in its own process and communicating via APIs. If you've been around SOA for a long time, probably not much in here that's super revolutionary, right? I mean, this sounds very familiar. We've been talking about this pretty much since networks first went online. I think the maybe one piece that's a little bit more revolutionary is this running its own process part, so it's all kind of encapsulated and stands on its own. But the one that stands out for me is this, a suite of small services. So this is a big shift from how we've developed applications in the past, this idea of having smaller services that are distributed. And it's not a technological change, really. I mean, it is in terms of how we're serving it. But at the end of the day, it's really more about the mental approach. I can hear myself breathe with this thing. It's really about that mental approach to how I structure and design an application and how I design the services that are going to serve it. And so thinking from that point of view, it really is sort of, that's to me the most revolutionary part of this. And this is the part that we're moving forward on. It's changing our kind of mental state when we talk about services. So this kind of comes from this idea of comparing microservices to the old school monolithic architectures where everything is in one server, one system, the application's designed top to bottom in one spot. This actually eventually begat N-tier architecture. That was kind of our first approach to start breaking that up a bit. And it allowed for some additional scalability with N-tier architecture, but still it wasn't as scalable, it wasn't as resilient. We had all kinds of issues with that. And so microservices, this is sort of the mental model that we're supposed to have when we think about microservices, this perfect world where the user interface and the logic and the application, the client kind of sits apart from all these individual services that stand alone, that are decoupled, that are stateless, that are able to serve that information up. This kind of perfect idea of microservices. If there's one thing I want you to get away from this talk today, it's that this is a lie. And I'm going to spend the next few minutes trying to explain why it's a lie and why it matters when you need to wrangle these things as you're growing. So to start kind of proving my point, where do microservices live? Where do they come from? Well, obviously, a lot of microservices still come from hand artisanal code created by folks living in the Silicon Valley doing the hard work to put interesting services and applications together, barely getting by on a meager 6-figure salary. It makes me weep. But I mean, coding, obviously. We're going to be coding the stuff, and we're going to explore those services and where they're hosted. Export those services, I'm sorry. Wherever they're hosted is kind of independent. It's based upon the application. It can be an Nginx server. It can be a standalone server. We talk about containers being the way that we serve this. So we'll take those applications, put them in the containers, kind of be able to manage them that way. We're seeing a big movement right now toward actually using containers as the way in which we install applications. For example, at TIBCO, we have BusinessWorks, which is kind of the standard install it on a giant application server and call it a day. And we also have BusinessWorks Container Edition. So we're actually selling it as a container that you can then manage using Kubernetes or Docker or whatever kind of system you have in place. Now, I want to take a quick moment here. I really dislike this mental image of containers. I think it was a mistake that this is the direction we went in because I like the idea that these are supposed to be some kind of a standard size, everything's encapsulated, I can move it from place to place and know it'll work just fine. But I still think the mental image, especially for non-technical people, isn't really there. I think a better image would be something like a guitar stomp box, an effects box, right? It's got inputs, it's got outputs, I can adjust the parameters, and it's all kind of hidden in a black box that I don't really have to worry about. I just know it's there. And I can put these into a workflow so that they're all connected together, creating new and interesting effects in real time while I'm on stage. So you're also getting live event processing. So when you hear containers, don't think of a box. Try to think instead of this other box that has actual inputs, outputs, and parameter adjustment. That's probably the better way to think about it, especially when we're talking about microservices, because that's what it is. It's an application that lives alone in one of these containers that's exposing its service through APIs. And then we're starting to see this emergence of, some call it serverless, some call it iPaaS, function as a service, this idea of smaller functions that live in the cloud that are fairly easy to create, compose, scale, and are actually hosted in some managed service. TIBCO has the TIBCO Cloud Integrator, which allows you to do this using Node.js applications. Lambda kind of does the same thing, so it's function as a service. We're seeing more and more of this. When we're talking about microservices at all these conferences, this tends to be the slide that people show, and then we move on. But here's the reality. There's a lot more to it. If you've been in business for any period of time, you have legacy code, and you can't just rip and replace that. That's a tremendous investment that's been made and put in place, and that data that runs your business still lives there. So you need to be able to leverage that information and make sure you can leave this in place until a time comes when you want to make the investment to replace it. And the way that you do that is putting some kind of an abstract layer on top of that legacy code so that you can leverage it, make it faster. Kind of a thin layer. We use ESBs like I already mentioned BusinessWorks. JBoss can do this. There are lots of other ESBs out there that kind of make that easy, and you can make that work. But this becomes a source of services, and it can be structured to look like microservices, even though this is more likely going to be some kind of an end-tier or monolithic application. And then the other services that we're starting to use, or we have been using, I'm at an API conference. This is it. We're talking about using third-party APIs. Why would I build a new service that checks the weather, that calculates sales tax when that's not my core competency? I'm going to go find a partner, somebody who's going to provide that data for me, and I'm going to use those APIs. So when I'm creating a new application, it's going to be a composition of legacy code, small microservices I've built within my own systems, third-party APIs, all of that coming together. So that this model we have of this kind of monolithic application giving way to a microservices application shifts. This becomes the center model, this perfect idea of what the world's supposed to look like. But the reality is, this is how most companies are now working. Unless you're starting from scratch and you're a brand new startup, this is how you have to work. I have third-party APIs that are serving stuff. I've got my legacy stuff that I'm now converting into APIs. I have microservices. This becomes a much larger deal. So the scope of services that I need to watch over and manage goes beyond my own data center. It goes beyond the new code that's being created. And I really need to make sure that when I'm planning ahead for this, I'm taking advantage of this. Because what happens when these services start to break? I have no control over a third-party service going down. How do I make sure that I can recover from that quickly? What happens when that legacy system starts slowing down and freezing? What happens when I'm starting to push it to its limits? How do I fix that? Well, I mean, those microservices, I built those. Those are great. They're small. They're easy to take care of. They break too. There's no such thing as perfect code, folks. And so when this stuff goes down, how are my applications going to respond? We've seen over the last few years this kind of thing cascade across the companies that we see hosted in the web, particularly software as a service companies. When AWS goes down, the web goes down. And it's not just because everything's hosted on AWS, it's because a large number of things are hosted on AWS, and a large number of providers over here who might not be on AWS are relying on the services coming from them. But they're not degrading in an elegant way when something goes wrong. The time to plan for API and microservice management is now. It's when you're starting to say we are going to adopt a microservices architecture. When you have made that decision, you immediately need to start thinking about, how am I going to manage this? How am I going to make sure that my application and my users are able to continue to respond even when something goes wrong beyond my control? And successful management is the only way to do this. Now, when we talk about any kind of application management, there's really, to my mind, 3 primary elements that you need to focus on. And microservices is no different. So the first one, Document at the microservice level. I got to tell you, actually, I really struggled trying to come up with the best way to explain this. So I'll tell you what I mean in a minute. But it's really keeping that documentation, that information about the services that are available at the level of the microservice and letting them carry it as they go along so that they can exchange that, provide it to the configuration system for their API management system, what have you. So the way they communicate. Monitor every single service you use. You've got to think in terms of how you're going to keep that stuff up. And then centralize administration and access. Make it easy so that you have a single source of truth, not only for your developers, but for the folks who actually have to administer this entire system. Documenting at the microservice level, to my mind, means really making sure you have a strong definition in place for the services each microservice is offering. Now, whether you do that in OAI, Swagger, whatever you want to call it, or Blueprint, if you saw this morning the way that Adidas is handling this, they're echoing exactly what I'm saying here. This idea of, they're using Apiary's Blueprint to do that. And that's a phenomenal choice. It's actually a really nice tool. Swagger is kind of becoming the standard for a lot of folks. So if you haven't made a decision, that's one way to do it. But it's still not super complete to provide every aspect. So JSON schema is another popular one. Typically what we do, though, is we'll take these definitions and we'll kind of put them in one giant file that gets hosted and broken down at the API management or the documentation layer, and we just kind of keep it in one place. It would be better instead to have smaller documents that only define the services provided by the microservice and to have that hosted at the microservice level, possibly taking advantage of the option header as part of the HTTP if you want to keep it RESTful. So that if I go to the option header and I make a request to find out what's going on with this particular service, I'll get back a Swagger doc that shows me everything that's capable there. The benefit of doing it this way is if I'm going to then deploy this to an API management solution, I'm going to put some kind of testing in place so I can continuously test it, do my regression testing, making sure that the contract is valid, etc. This becomes the lingua franca that allows that to happen. And by having that definition carried with the microservice, I never have to look for it. I never have to worry about that. I never have to wonder where the best place is. It is responsible for registering itself in any system, and it's responsible for its own configuration. And then when you're looking to aggregate that, you can take the individual ones, aggregate them to a single document, and update that and change that as you go. So it becomes sort of a schema management situation at that point. But this, to me, is the right way to start handling this documentation at that layer. And when you're doing this, it can be really frustrating and take a long time to put that kind of description in place. And we're starting to see a drive toward modeling and mocking tools that allow you to, in a visual way or potentially in a code-driven way, start defining what these APIs look like, and then create mock-ups with mock test code so I can validate that the interfaces I've created are actually going to work the way that the business requirements need them to work. Starting with that kind of that design-driven approach, where I'm designing the interface first, I'm securing that, and then I'm building to the contract. That's becoming the better way to start your projects as you're looking at microservices and you're looking at serving these things out and helping folks out. Because if I know what that contract is going to look like, I can avoid a lot of the versioning issues, I can identify problems early on, and I can actually iterate over this pretty easily. You also need to make sure that you are monitoring every service that you have. Monitoring goes beyond the standard logging. I think having event processing to understand what's going on, be able to react to that, have a business process management system in place so that when something goes wrong, it's being routed to the correct person who can rapidly go and address it. You need to have that in place too, but that's kind of advanced. At the very basics, you need to have some kind of way to structure the data that you're collecting and index it. You need to be able to aggregate the logs across all of your services into a centralized location so that you can get that 360 view of what's going on with all your services. And then really importantly, you need to have a great data visualization tool so you can see at a glance what's going on. The best tools are the ones that are not just going to show you fun graphs and stuff like that, but are actually going to build the network graphs in a live format so I can see how far the different nodes are, what kind of dependencies are on between those services, and be able to get a full picture of what's going on across all of my entire enterprise in one single, very easy shot. The open source stack for this that everybody seems to be adopting, and it's really popular and it's awesome. If you need to start somewhere, the Elk stack is the way to go. Elasticsearch, Logstash, and Kibana. The Elasticsearch handles that indexing. Logstash handles the aggregation of the logs, and then Kibana provides a nice visualization type interface. There's also a lot of commercial products out there. TIBCO. We have LogLogic. LogLogic actually handles the two things at the top. It does the work of Elasticsearch and Logstash. And then Spotfire is this really beautiful visualization tool that allows for live dashboards to make it really easy for you to dig in, drill down, and start playing with the data in a live window without being a data scientist or anything like that. It's a fantastic tool. There's lots of other great solutions out there as well. And so I encourage you to figure out the stack you want to adopt and figure out what that process is going to be to make sure that data does get collected and is reviewed on a consistent basis. And you need to make sure you monitor every service. In fact, you probably want to pay a lot more attention to the services over which you have no control. Those third-party services, you're not going to get access to their logs. You're not necessarily going to get access to their uptime schedules and all that kind of information. You need to take responsibility yourself to make sure that your system degrades elegantly when one of those services go down. And products like API Fortress that allow for that kind of monitoring in real time, that exists to make that easier for you. And then going back to this concept, you can use Log Fortress for all of your APIs as well. It's a really nice tool that allows you to do that. And one of the best ways to configure that is to provide a Swagger document that defines the API. It eases that configuration. So if you're working with third-party vendors and you're going to start using their APIs, I would encourage you to start asking them for their Swagger documents so that you can make these configurations easy for you as well. So with these services kind of existing across the board, third-party services in my own data centers, in my legacy systems, they're kind of all over the place. And trying to hunt down where they're located gets to be a mess. I want to make sure that we're able to distribute those services, but have a centralized view of where they are. And this is where platforms like API Management, TIBCO Mastery, comes in to make this a little bit easier for folks to get that single source of truth or that single pane of glass view. Now, traditionally, when we talk about this, we're talking about developer portals. I need to have that one home page that I can go to register for my account, get my key, get my documentation, ask my questions. I don't want to have to hunt around. I don't have to do it based on whatever service you have. I don't really care about the internal structure of your company. So if Team A runs this set of APIs and Team B runs this set of APIs, I don't want to have to go to both Team A and Team B. I want to have one place where I can get that. But the same needs to be true for your administrators. I don't want to have to hunt down the reporting tools. I don't want to have to go look at the logs myself. I don't want to have to hunt all this down. I want to have a central location where I can see all the services we have available. I can repackage those services. I can see who our developers are and what they're using. Don't make the administrators hunt this down. Give them the portal they need. Once you start implementing this and you have this management in place, these problems can start fixing themselves. You can start degrading elegantly when things go wrong. You can replace that microservice more rapidly because you know that, well, it went down and things are broken. I can unfreeze my legacy application. And when those third-party services come back, I'm ready to go and I'm ready to serve my customers again as if nothing had happened. More importantly, this is a really, really narrow view. This is a little bit more realistic. These services are going to grow. They're going to expand. And if you want to be, I don't like the term future-proof anymore because future-proof is a lie, but future-tolerant. If you want to be more future-tolerant, you want to make sure that you're managing these services as best you can. And following these three basic elements, just getting that in place first and starting now will help make sure that you can remain future-tolerant no matter what comes next. Thank you very much.